DISRUPT has made anything clear this year is that we're going through the early stages of a technological revolution. Generative AI is here to stay, but this technology has a massive contingency. A single ChatGPT query requires 15 times the amount of energy as of a standard Google one. The result of this, by 2040, 20% of the world's energy will be consumed by data centers alone. But the problem isn't modern cooling capabilities, but rather modern cooling inefficiencies. The majority of the United States' $55 billion data center market are small to medium-sized fragmented co-locations that aren't privy to the organization, the modern technology, or the insights required for the necessary optimization. This is where I, Chase Overcash, CTO of FLUIX, and my co-founder and CEO, Abhi Sastry, realized that we could support the ongoing technological revolution by minimizing that constraint. And so today, I'm happy to introduce AIMI, the artificial intelligence for managing infrastructure. You can think of AIMI as automation for critical infrastructure. AIMI can integrate and optimize all those fragmented systems inside the data center environment, including HVAC, lighting, and water cooling. This allows AIMI to learn from and manipulate all levels of the data center environment, allowing it to make changes that our competitors cannot. This gives us the incredible insight in order to make a total energy reduction of 40% across our 5 paid pilots, resulting in FLUIX making $300,000 in revenue. And so it is easy to see why FLUIX has $350,000 in banked investments. And if you're curious why the Morgan Stanley themselves have come in at $250,000, I invite you to come visit our booth in the sustainability section, where we are previewing our exclusive demo today, just for TechCrunch DISRUPT. Thank you.
Thank you. I'm curious to hear more about what sorts of parameters you're taking into the model, and then how you're using that to tweak to achieve those kinds of savings.
Yeah, so in the simplest sense, what we are doing is making sure that the data center is running safely, but efficiently. Currently, data centers oftentimes just run their HVAC units all night because they don't want to risk the safety involved of changing it. Nobody's going to come in at 3 a.m. and manually change it, and the data centers are fragmented, so if you change one, you don't know how it's going to affect the other. So we're trying to get all the parameters reasonable within the data center environment, so including outside temperature, outside humidity, the set points of all those data centers, and how the sensors around the data centers gives us insights on what those changes do. And so we can make those decisions at night in order to turn off the cooling. We're also taking into consideration load. How much pressure is the data center under at each point in time, and so that we can predict and react to those changes in advance.
Excellent, very cool. Thank you, FLUIX.
All right, thank you.